Hello and welcome. In this video, we will solve the Leetcode problem to find the length of the longest increasing subsequence. I will firstly explain with an example what a longest increasing subsequence is, and then I will explain how we will solve the problem. So let's take the example from the problem statement. So in this array, what we need to do is we need to find the length of the longest strictly increasing subsequence. Now, the meaning of strictly here is that if we have an element which is the same as the previous element, then that is not counted. So let's firstly list out all the increasing subsequences in this array. So we would start with 0, then 3 is greater than 0, 1 is less than 3, so we'll skip that. 6 is the next one, and we'll skip 2 again because it's less than 6, and then lastly 7. Then we'll go to index 1, start at 3, and the next one is 1, but 1 is less than 3. We'll skip that. We'll go to 6. That's our next increasing element, and finally it's 7. This is the concept of increasing subarrays. So I've created an example. I will step through it and explain how the implementation will work. So firstly, we have an array which is the input array, and we need to find the length of the longest increasing subsequence. The first step is obviously to build out the subsequence, and then we need to calculate its length. Now we need to do this in an efficient way. So to solve this problem, we will maintain a list which will contain the longest increasing subsequence, and we will add elements into it as we iterate through our input array. So firstly, we would have the element 0 in it. Then because 8 is bigger than 0, we'll add 8 into the array. Next we would hit 4, and now notice that 4 is less than 8, so we can't simply add 4 or append 4 into this array. What we would need to do instead is use binary search to find a location inside of this subarray where we can place the number 4. And using binary search, we can place the number 4 after the element 0, so it would replace 8. Next number is 12, and because 12 is bigger than 4, we simply append it to the subarray. The next number in the input array is 2, and because 2 is smaller than 12, we need to find a place inside of the subarray where we can put the number 2. So obviously 2 is bigger than 0, but it's less than 4, so it would replace the number 4, and we would get 0, 2, and 12. So the next one is 10, and because 10 is less than 12, we can't append it, so we would need to find a place where we can insert the number 10. So that would replace 12, and we'll continue in this manner till we have iterated through our input array, and we will end up with a subarray with 6 elements. So in the case of this input, the length of the longest increasing subsequence is 6. Now let's start writing out our code. Firstly, I'll create a list to store our subarray, and I will add the first element from the nums into this longest increasing subarray, and I'll add the first element into this subarray. Next, I will iterate through the remaining elements of the nums array and then add the elements in the subarray. We first check if nums of I, which is the current element, is bigger than the last element in the subarray. If it is, then we simply append it. Else, we need to find the index inside the subarray where we will place the current element. Once we found the index, we'll simply set the current element at that index in the subarray. Once we have looped through all the elements in the input array, we will return the length of the subarray, and that would be the length of our longest increasing subsequence. Now let's define our method. It will help us to find the position where we need to insert the value in the subarray. Because I'm going to use binary search, I'm going to define the low and high, which will be initialized to 0 and the index of the last element respectively. Next, I'm going to start by dividing the array into 2 halves. And I'll continue dividing the array into 2 halves till my array is so small that I can no longer divide it. That is why the condition low is less than equals high. So I'll now define the index to point to the middle element. Let's extract this middle element into a variable. We'll first check if our value is at the middle. If it is, then we simply return the mid. If our value is bigger than the middle element, then we discard the first half and we search in the second half. Else we discard the second half and search in the first half. And finally, we'll simply return the index low, because that would contain the position where we need to insert the value at the end of this while loop. I hope you found the video useful. Please do click the subscribe and like buttons and remember to share the video. Thank you.